Right. Good morning. Thank you, everybody, for inviting me to this meeting. I'm Jason Zurawski from ESNet, and I was going to be talking a little bit about a program that we recently just completed with the high energy physics community with the help of Jeremy and Abed from DOE SCHEP, and some of the outcomes and a little bit about us and how others who are attending this meeting may be able to get involved with us in the future. So real quick agenda, and I do have a little bit more slides than my time will allow for. So these are posted to the Indico page so people can take a look at them afterwards. I'll probably end up skipping a couple of them. But I wanted to go over a little bit about our requirements review program and how it relates to the high energy physics community, a little bit about the process itself, why we do this, and how we engage with other areas of DOESC, and a little bit about the outcomes of this most recent activity and how we hope to engage with you all in the future. So for those that may not be aware of ESNet, we wanted to at least provide a one-slide summary of who we are. We're a DOE facility, just like a lot of the other facilities that you may be familiar with, except we're a nationwide facility that provides networking. And we hook up all of the national labs, and we do have connectivity that supports a lot of the research that may go on at universities as well. And we like to consider ourselves the circulatory system of the science complex, because if you are engaged in some form of scientific activity at a facility and you're trying to access it remotely, or you're involved in data transfer, whatever the case may be, you're most likely using ESNet under the wire, so to speak, and you may not be aware of it. And our goal is to be as transparent and high performance as possible. So we're there to provide reliable, high performance connectivity wherever you may need to be reaching, whether it be another lab, a university, an international location, and in many cases, cloud resources. So because of that, our core mission is really to serve all of the DOE science programs. And the biggest things that you'll probably interact with us will be large-scale data movement and other network services that are going to be sort of enabling basic scientific activity. And to do our job effectively, we try to understand the needs of the science communities as best as we possibly can. And the way that we try to do this is by profiling the large facilities that are in each of the programs, the major experiments that may be going on internationally or domestically, individual PIs, whatever the case may be. But we try to understand as intricately as we possibly can the scientific instruments in the facilities and how they operate and what their data and growth patterns are going to be, what that process of science is, how people interact with networks and computation and instruments, and then how these are going to change over time. And then once we sort of get this picture, we're able to then publish a report and then set our strategic goals based on what we need to do to support the scientific activities. And these are two graphics that I've borrowed from Ben Brown over in Oscar. But the goal here is that we want to try to have a vision where data is really driving a lot of the different components that interact with that data, instead of the other way around. We don't want to build a network just for the sake of building a network. We want to build a network that is able to handle the data aspects. And we want to make sure that we are linking that data to the storage, the computation, the algorithms, all the different things that are involved in the process itself. So to that end, this program that we've embarked upon, and it's about 20 years old at this point, it's an attempt to try to answer all of the different questions about how to support scientific activities. And we will go and we will visit each of the major experiments in the facilities over time, usually every 3 to 4 years. And then we ask a couple of generic questions, but by asking these questions, we're able to dig a little bit deeper and figure out how we need to prepare our own sort of infrastructure to support this in the future. We ask about that process of science. We ask about the volumes of data produced now and the anticipated volumes that are going to increase in the future. But we're specific and deliberate about the questions that we ask in this area. We do want to try to understand where geographic locations play into things, where the data needs to be shared, computed, stored, where the different collaborations may be existing. And then we also try to understand what the current technology capabilities look like, whether it be the network itself or the use of new and emerging computational technologies, where storage may or may not exist, how the software stack is going to change. all the different components of the way that the science will be enacted. So the inputs to this process are pretty specific, but also not very challenging for the scientific communities that we work with. We do this via a shared document structure, and we try to make it as easy as possible because we know that everybody is busy. And as a result of that, we ask a couple of simple questions to start off. We may ask some follow-up questions later, and then we try to all get together into a room to sort of go over the results and then talk collectively about the way that we can try to assist and help in the future. But the basic questions are going to be revolving around the collaboration space, the data production space, and sort of the process, how it's analyzed, exchanged, and interacted with. And then the outputs we get out of that are much greater than the sum of the inputs that we really ask for. We're able to go back and look at the different technical gaps, bottlenecks, and opportunities that all the different scientific communities give to us. We're able to then respond with new or existing network services that may be helpful to these in the future. We're able to get a good understanding of what our capacity needs, particularly in regions where sites are located or we may see increases in demand. Mainly if we have to put new connectivity in place to support an emerging collaboration, or if we need to augment other areas as well. And last, and probably the most important, is we do want to try to create these long-term relationships with the PIs, the staff, the project management team, all of those different things so that we can provide ongoing consultation and support. And this is what we value the most. A lot of the relationships that we build during this process, we're able to go back to these groups over time, see if they're doing okay, and then they're more apt to come to us and ask for assistance when they need it. So I'll go over a little bit of what we just completed with the high energy physics community, which started last year, and we're about to get the report out the door in about a week or two here. It's in its final review stages right now. But we had 14 different scientific case studies that we went over, and 7 technical case studies. And the only difference here is that a technical case study is reviewing the IT infrastructure of a specific facility, where a scientific case study is looking at the actual science that's going on. Overall, about 125 authors from 38 different organizations. This is about a 1-year process. We had an in-person meeting in I think either September or October of last year to sort of go over the rough findings. And then we've been in the process of getting the report out the door since. And there'll be about 524 pages in the final report. The more important thing, and I'll go over a couple of these near the end of the slides, is some of the actions that we got. And these are things that we are going to follow up on with the community to honor some of the things that are either areas of friction or areas of opportunity that we can work on collectively. So these were the different experiments and facilities that we profiled this last time. You'll notice a lot of very familiar names within the community here. And then this is a bit of an eye chart, but these are all the different facilities that universities, facilities, PI locations that we interacted with over the course of this activity. So I don't have a DOI for this most recent report because it's just not out there yet, but it should be out there in the next couple of weeks here. This is one that we produced the last time, of which Heidi was very involved with. This time around, we did focus on a lot of the same activities, particular focus on HL, LHC, Dune, Rubin, but we also added in a couple of new ones that we hadn't talked to before. We also focused heavily on a new DOE initiative called the Integrated Research Infrastructure, which is an effort to try to ensure that we are building scientific infrastructure that can help in the future, whether it be efforts to try to unify APIs or ways that we can reduce the friction of federated identity or improve networking computational capabilities. So the things that we generate out of this report are sort of 2 areas of data. We have findings, which are facts and observations that we try to push forward as being, particularly good for this community. But then also these actions, which are potential strategic or tactical activities. And every single action is going to have a group of people that are going to be trying to work on that in between the period of time when we do this report and when we revisit the community in a couple of years. So in general, none of these will probably be surprising to anybody, is that we're seeing trends of data volume increases across the board. I believe that we're now really in the petabyte era for a lot of the experimentation, and even into the exabyte scale for a lot of the big experimentation will be coming very soon. Storage is still an issue for everyone, whether it be a large collaboration or a small collaboration. One of the comments that I loved from this report that I'm going to pull out here is we still treat the network as infinite storage. But I think a lot of people view this as not being a sustainable way forward. Almost everybody is really involved in multi-facility workflows, and this is really a testament to how well networks have worked for people now, where we can trust networks to sort of link together computational and instrument facilities, and we hope that this trend continues into the future. A lot of people are dabbling with cloud use. There's a significant number of workflows that can be deployed onto cloud resources, but the cost is still rather high for people. And some experiments really have taken this to heart, and they've built sort of hybrid models where we have cloud front ends and DOE-based resources on the back end. So we're seeing this as a trend that'll probably continue into the future. And then for the LHC community, the data challenges that they've conducted have been a really good thing for preparation for high luminosity. And then a couple of selected findings here that I pulled out just because I think they're rather representative here. Network speeds between major HPC centers are no longer a limitation for people, where a couple of years ago this was a problem. Transferring petabyte data sets is effectively routine, so we're very happy about that. As I noted before, data sets are expected to increase in the coming years, but this should be well within our capabilities to handle. Another one that's related here is, given the volume of data involved, it's infeasible to make all this available for the duration of a project. So many projects, are having to resort to putting data onto cold storage resources, whether it be tape or whether it be Glacier or something like that. So storage still remains a major factor for making all data available at all times. And then lastly, removing the need to worry about data locality is really allowing researchers to spend more time on the science. So ensuring that we do have technology available for supporting networking and computation and storage that all just works and integrates into the experiments has been a huge win for everybody. So in terms of future work, I'll summarize it by just saying that, even though we are a network, we're not just your infrastructure. We are a part of the process of science, even if we may be a little bit invisible to it. We have a long history of direct engagement with these HEP communities. After the last requirements review program in 2020, we re-engaged with LHC and Rubin and Dune and many others on a lot of their areas of friction, and we have regular meetings with all these communities just to make sure that things are going okay. This goes to anybody, though. If you can involve us either early or late, we can help you identify possibilities for joint efforts. We have a pillar of our program called co-design, where we come in and we try to suggest ways that you may be able to effectively use networks to do your research. So that's our general email address that you can reach us on, engage@es.net. And we're always happy to talk to anybody from the community about ways that we can try to help. So that's it for me. I'll just leave that up there for a second if anybody needs to write that down, but I can answer any questions if they came in.
Are there any questions? I'm not seeing any right now on the live document or in the chat. Participants are welcome to just raise hands.
Oh, well, I think we just got one in the chat.
It's a remark.
Oh.
For a copy of the new HEP requirements review report when it comes out, or other questions, you can reach ESNet at engage@es.net. Well, thank you very much, Jason. Shall we?
Yeah. I actually was going to ask a question. I didn't have time to type it, but so Jason, you know that what I'm interested in is getting ESNet to South Dakota. Could you comment on that project, and also how having ESNet in an area can benefit local communities as well as just the scientific enterprise?
Yeah, absolutely. So what Heidi is mentioning is ESNet connectivity to reach surf in South Dakota. And I'm not actively involved in this project, but the last time that I did talk to the group that is, we've spec'd out everything. So at this stage, I think that we're working with the local regional provider in the state. I believe their name is REED, R-E-E-D. And we have some quotes on circuits, and we're all set to go with regards to getting it all connected up. But I think that the challenge is always with just getting the funding put in place. So once the funding gets put in place, we're going to be able to execute on those contracts. And I think that the goal is 2x100 connectivity into the facility so that we have a primary and a backup. And then that'll support the scientific mission of Dune and everybody else who's currently occupying the surf site. And to your second point of how we're able to sort of engage with local communities, because we are a mission network, our goal is really to support the DOE science mission primarily. And much like we're doing in South Dakota, we're always going to engage with the local regional optical network where we possibly can. And in many cases, we want to use their infrastructure to deliver services. And if they're unable to provide that, either due to their own funding or their inability to reach it, then we're able to put in some special considerations so that we can try to link up different facilities.
Okay, thank you.
We have a question from Liz. Go ahead, Liz.
Sorry, I was unmuted. I wanted to know a little bit more about what you say about the IRI. Could you expand on that a bit?
Sure. So the IRI effort transcends more than just ESNet. This is it's run within Oscar, but it has representatives from a lot of different Oscar facilities and several different excuse me, other representatives from the other areas of Office of Science. And I believe the effort is now about 1.5 years old, maybe a little bit longer. They've sort of started the process of identifying some Pathfinder projects. And what these are aimed at doing is taking, a workflow that may exist today and trying to integrate it into the broader ecosystem of being a multi-facility workflow, or trying to address some area of friction that they may have identified. So one example, and the only reason I'm going to use this is because my colleague is heavily involved in it, so I've helped him a little bit, is from the fusion community, where they're attempting to try to link up General Atomics and D3D with a high-performance computing facility, in this case, NERSC, and then use that as a way to try to do their real-time workflows of fusion reactions. So the early days of this have all been just trying to do the quote-unquote easier efforts. But the broader goal here is to be able to identify many different aspects of DOE science and categorize them and quantify them and try to address all the different needs that they may be bringing forward, whether it be trying to operate at multiple facilities using shared APIs, or whether it be working on authentication issues. There's a litany of different things. There's an entire report that I think is linked off of the ESNet website. If it's not, I know that it's also available on OSTI and some other resources. That goes into a lot more detail than I can possibly give with my answer.
Any other comments or questions from the community? If not, thank you very much, Jason. I'm sorry, we just got a question in from Stephen Gottlieb, so maybe just pause for a second. Jeremy, the question that came into the previous speaker is, I use both NSF and DOE centers in particular. Ranch at TACC is a main data repository. How do you coordinate with NSF centers? Are you still there, Jason? He can't unmute.
I'm going as fast as I can.
Okay.
There we are. Great question, Stephen. So yes, we do coordinate with a lot of our brethren over in the NSF world. So for TAC in particular, I don't think we have a direct peering, but we do peer with their regional provider, which I think is called Learn within the state of Texas. So, if you are experiencing any form of sort of friction in trying to get your data in or out of TAC, you could always use that email address that my colleague Kean hopefully posted into the chat above, and we'd be happy to coordinate with them. We do this a lot. So if you are experiencing data transfer issues from your site to TAC or to any of the DOE facilities, we're always happy to step in.